Welcome guys. Today we're just gonna look into tutorial 1 of 2020/2021 Intake Physics 101 on the topic vectors. So directly let's go to the tutorial. So to start with, we'll start with looking at our first question, which says a displacement B of 100 meters from the origin at an angle of 37 degrees above the x-axis is a result of three successive displacement. B1, sorry for an error, this is B1. So it says B1 of 100 meters along the negative x-axis, B2 of 200 meters along the at the angle of 150 degrees above the x-axis, and a displacement B3. Then the question says find B3. So what we're interested in is here, finding B3. Okay, so you can pause this video if you want to try out solving the question, so before we solve together. Okay, so let's look at the solutions. So for us to answer, we've got to understand that the displacement B is a result of three successive displacements. And if that is the case, then it means that B, if I write B here, B will be equal to B1 plus B2 plus B3. All right, that will have it. Then if that is the case, B3, which we are looking for, which is our interest, B3 will be equal to B minus B1 minus B2. Okay, then we know that B, from what we had, allow me to do it this, we know that B is equal to 100 meters, then 37 degrees above, from the x-axis. This is the positive x-axis. Okay, positive x-axis. Then B1 is 100 meters along the negative x-axis. Then B2 is equal to 200 meters at an angle of 150 degrees from the x-axis, so from the positive x-axis. And B3, which we don't know yet, we're yet to find. So what you do is you sketch your values so that you can have a clear picture of what is going on. So they say if we use an x or y plane, this is my x or y plane, would you like that? So our B, which is our resultant, was there with 37 degrees. So this is B, is 100 meters. Then we have our B1. So our B1 was heading this way, this direction. That will have our B1. So B1, 100 meters. Then we have our B2 moving in that direction. So that will be our B2 having 200 meters. Okay, then with an angle 150 up to there, 150 degrees. Okay, so once we get to have that, what are we going to do? We're going to dissolve this into components. You agree with me that this B here has an X component, all right? So the B3 has an X component here, and also a Y component, which is there. Okay, same as with B2, it also has an X component and a Y component, because it is a resultant of the X and Y movement vector, I can call it. Okay, so we're gonna dissolve them into components. So how do we do that? So what we do is we write our table. Okay, so our table will look like this. So you have your X component, or B cos theta, and your Y component, that is the B sine theta. Remember what I said in the y-axis, that is the Y component, that it has if this is our line there, then it has, and we have an X or Y plane, So it means that this line has a component in the y-axis and a component in the x-axis. So in the x-axis, that's the one we're having as b cos theta. Then in the y-axis is b sine theta. All right. Okay. So now we go to our filling in of our table. So to start with the b, so the b, we have 100, so it's 100. It's gonna be 100 cos theta. What angle is 100 degrees at? Our b, that is 37 degrees. 37 degrees, giving us what? That if you punch on the calculator, you get 79.86 meters. Okay, then here we will get 100 sine theta 37 degrees. So this is gonna give us 60.18 meters. Okay, we come to our b1. Our b1 is also 100. So it's a cos. Remember, our b1 was along the x-axis. So along the x-axis, meaning this side, the negative x-axis, it was approaching the negative x-axis. So it was at 180 degrees. So b1 cos 180 degrees. Yeah, it was along the straight line. Then cos 180 degrees, so this will give us minus 100 meters. Okay, then 100 sine 180 degrees will give us 0.0 meters. Okay, then the other one we have is a 200 cos 150. So this was at 150 degrees from the positive x-axis. So this will give us minus 173.2 meters. Then a 200 sine 150 degrees. So this will give us okay. So this will give us 100 meters. Yeah. Then our resultant. So to find the resultant, you add these values. You add the values that you are getting. For the x, this is for the x. For the x component, you add 79.86 plus 100 meters plus minus 73. So when you add them, our resultant will be minus 193.35 meters. Then in the y-axis, sorry, this is our resultant in the x-axis. Then our resultant in the y-axis will be 160.18 meters. Okay. Now, what do you do? After having that, take note of the figures. Okay, so b3 of x. So you start with the b3 of x. b3 of x will be equal to b of x minus b1 of x minus b2 of x. All right, so that will give us, if we impute in there, we have 79.86 meters plus 100. Sorry, so this one was minus 100 meters, then minus 173.21 meters. Okay, so if you add them, though, this will give us 79.86 meters plus 100 meters plus 173.21 meters. So the total give us so b3 of x will be equal to 353.07 meters. All right, then you go to the y-axis. So it's a b3 of y will be equal to by minus b1y minus b2y. So the y values that we add from the table of the y component, where b was 60.18, then minus 0 meter, then minus 100 meters. Okay, yeah, so what we get here will be equal to minus 39.82 meters. Okay, so keep in mind of these figures and hope that you are following. So what we'll do next is to find the magnitude. So to find the magnitude, with B3 of B3 will be equal to the square root of B3x squared plus B3y squared. Okay, yeah, so this will be equal to the square root. Remember, our B3x was 353.07 meters squared plus by was minus 39.82 meters. Then you square it. Okay, so this is going to give us if we square directly, to give us, you punch on the calculator to give you something like 355.31 meters. Yeah, so our B3 in magnitude will be 553.31 meters. Now, the other thing we're supposed to do is to find the angle of B3. So how do we find the angle of the B3? So to find the angle, we say tan theta is equal to B3y divided by B3x. Remember, our B3y was minus 39. So in this case, we'll not take the minus with us, but we'll forget it. Minus 39.82 meters divided by 353 divided by 353.07 meters. So the meters will cancel. Then this will give us theta will be equal to the tan inverse of 0.11278. So our angle theta will be equal to 6.43 degrees. Now, the angle, our theta, our B3 is in the fourth quadrant. Okay, so the angle is in the fourth quadrant. What we'll do is, tan is positive in the fourth quadrant. So what we'll do, our angle is in the fourth quadrant. So what we'll do is, since our theta is equal to 6.43, so we'll say theta will be equal to 360 minus 6.43. So our theta in this case will be 353.6 degrees. That will be our final answer. Okay, so let's look at the next question. Okay, so our next question says, three vectors A, B, and C are shown as below. Find the magnitude and direction of the vector D, which when added to these vectors will give a zero resultant. Okay, so our vector A, can give this vector B, vector A, vector B, vector C, or in a clockwise, anti-clockwise way. If you give it in a clockwise way, it's fine. You give it in an anti-clockwise way, it's also fine. Yeah, so for us, we'll go with a clockwise one. So what we do is simple and straightforward. We just use the component dissolving procedure, or component dissolving approach. So let's quickly do this one. Okay, so like we did in the the previous example, the previous question, we dissolve into components. So likewise, the x-axis, so this will be 210 cos. So the angle here, the angle here is 180. It's along the x-axis, 180. So 210 cos 180 on our calculator will give us minus 210. Because we know that 180 is equal to cos of 180 is 1. Is minus 1. Then on the y we have 210 sine 180, that's the angle. So that will give us sine of 180 is 0, so everything will become 0, meters. Then this one here we have 180 cos the angle is 45, so that will give us 127.28 meters. Then the other one is 180 sine 45, sorry for that. So it will give us 127.28 meters. Okay, the other one is 110. So the 110, we'll say, since it is here, now when getting the angles, you get from the positive x-axis. So what that means, you get from this line here, going that way, and in an anti-clockwise manner. So in an anti-clockwise manner. So what we'll do is we'll add 270, because we know that at this juncture here the angle is 270. Here it's 0, 90, 180, 270. So we'll say 270 plus 60, that will give us a 330. So that's the angle that we are going to use here. So it will be 110 cos 330, that will give us 12.54 meters. Then 110 sine of 330, that is going to give us minus 55.0 meters. Okay, then you add to find the resultant. I said you add these values, the minus 210 plus 127 plus 12.5, that will give us the resultant of the x value. So the resultant here, when you add, will give us something like 12. Sorry for this one, it's just an error. It was supposed to be 95.26. Okay, so it will give us 12.54 as our final. Then here it will give us 72.28 meters as our resultants. Now, what do you do with our resultant? Mind you, we are not done. We need to find the magnitude of this vector d, which we've been asked. So what we'll do next is finding the magnitude. So we'll say magnitude r will be equal to, magnitude is equal to the resultant of r, the modulus, the absolute value of r, which will be equal to the square root of rx squared plus ry squared. So in this case, we had our resultant in the x-axis was 12.54 meters, then square plus 72.28 squared meters. So that will give us 157.252 plus 522.398. So this is going to give us 5,381.6504, which is now our final one. With the square of this will give us 73.36 meters. That will be our final answer. Okay, now after calculating the magnitude, we need to find the angle of our resultant. So to find the angle or the direction, because the angle gives the direction of that vector, of a vector. Yeah, so we'll say tan theta is equal to resultant y divided by resultant x. Remember our resultant y was 72.28 meters divided by 12.54 meters. So this will cancel there. So what we get is 10 theta will be equal to 5.763 64. Yeah, so theta will be equal to 10 inverse of 5.764. So our theta in this case will be equal to 80.16 degrees. Okay, now we need to note that from what we've calculated, so take note of the 80. From what we've calculated, we'll have something like this. So our resultant will be here, 80.16 degrees. All right, so 80.16 degrees, then there's this side. Okay, this is our resultant. Okay, so if this is our resultant, then the vector D will just be more like a reflection of this our resultant, which is this extension here drawn in dotted line. So like here, yeah, so it will just be like more like the extension of the reflection of our resultant, because if we add this reflection, which we are not counting, I assume I can say we are not counting, to those vectors, those three vectors, it will give us a 0. So if this is a reflection, the only difference will be in the angle. So the angle will read from the positive x-axis up to D over there. So that will have we'll say 180. So from here to this point, remember we have something to take note of for angles. This angle here and this angle, they are the same. If they are the same, then we can add this 80.16 plus the 180, which runs on a straight line. All right, so we'll say theta, therefore our theta will be equal to 180 plus the 80 degrees 0.16 there. So our final solution will be equal to 260.16 degrees as the direction of our vector D. All right, okay, so let's go to the next question. Okay, so our next question says, if A is equal to open bracket 6.00I minus 8.00J units, B is equal to A minus 8.00I plus 3.00J units, and C is equal to 26.0I plus 19.0J units. Determine the value of A and B such that A, small letter A, or small letter A multiplied by capital A plus small letter B multiplied by capital B plus C will give us 0. So what do we do? So the approach that we are going to take is, while we make two equations, we come up with two simultaneous equations. Okay, so remember that A, so this is our equation. We've been given this equation. Here. Okay, so in this equation, what we have is A. Our A is, we can write it more like 8I minus 8J, then plus our B is our B will be 8, minus 8 B minus 8 plus 3 J, then I plus C. So our C is 26, I plus 19 J. All right, so this is equal to 0. Now this can be rewritten as 6 AI, then minus 8 AI, J, that format, plus minus B minus 8 BI, then 3 BJ plus 26I 19J. All right, this is equal to 0. Okay, so from there what we do is we'll separate the equations. We'll make two equations from this format. So we can divide, we can cut this through there like that. This is equal to 0, that is equal to 0. Okay, so what we get is 6AI minus 8BI plus 26I will be equal to 0. Then minus 8AIJ plus 3BJ plus 19J will be equal to 0. Okay, so from those equations, so our 6AI minus 8BI will be equal to 26I. That is our equation 1. Then minus 8AI plus 3B, this is B, sorry, J will be equal to minus 19J. That is our equation 2. Okay, so from there now we can solve equation 1 and equation 2 simultaneously. All right. Okay, so we can remove the i's and the j's. We remain with 6a, sorry for that one. Okay, so remain with 6a minus 8a will be equal to minus 26. Then we have 8 minus 8b plus 3b so this will be equal to minus 19. Oh yeah, sorry, here I was writing an a, it's supposed to be a b. Yeah, something like this. A, and here we have an a and a b. Okay, like that. So after having that, we can solve this. We can reduce the upper equation if we divide by 1 over 2. We multiply by 1 over 2. So we have the upper equation we get is 3a minus 4b will be equal to minus 13. Okay, then we have minus 8a plus 3b is equal to minus 19. Okay, so you can do this, multiply by 3, multiply by 4, so that we cancel out the so we have 9a plus minus 12b will be equal to minus 39. Then down here we have minus 32a plus 12b equal to minus 76. Okay, so from there we can do this. So the b will cancel if we subtract it. So if we added that, yeah, if we added everything, so when we add this, it's going to give us minus 23. A plus a 0 will be equal to minus 115, right? So we can divide by minus 23, divide by minus 23. So our A will be equal to 5. Then if that is the case, then we can substitute where there's A with our 5. So we can use the first equation, that is the 3a minus 4b equal to minus 13. So 3, 5 minus 4b equal to minus 13. So 3, that's 15. 15 minus 4b equal to minus 13. Then what that means is that minus 4b will be equal to 13, minus 13 plus minus 15, because the 15 here is going this side. So minus 4b will be equal to minus 28. So divided by minus 4, our b will be equal to 7, because it will be positive. Will be equal to positive 7. So our b will be equal to positive 7. All right, and there we have our answer. So the value of A will be is 5, B is 7. There. Okay, question 5 says 3 displacement vectors of a croquet ball are shown in the diagram below, where A is equal to 20.0 units, B is equal to 40.0 units, and C is equal to 30.0 units. That says find the resultant unit vector notation and find the magnitude and direction of the resultant So that is the diagram they're talking about. So let's look at the solutions now. Okay, so what we'll do here is, one, we start with the A. So the A there, if we dissolve them into components, so our A has, sorry for that one, our A with magnitude A equals to 20.0 units. Okay, let's do that. Okay, our A is 20.0 units. Then if that is the case, you notice that our A has no value in the X component. In the X axis. So our AX will be equal to 0.0 units. Okay, now in the X axis we use unit rotation A.0 I. Then our AY will be equal to B sine theta, which is equal to, our B is 20. So and our sine theta, so in this case our sine theta for B is 45. Our 20, our sine theta, we just have a 90 there. Yeah, so we have A will be equal to 20i. Okay, all right, now let's look at B. Okay, so our B, sorry for that one, let me use a allow me to just use a green one. So our B, which is 40 units, so our B of x will be equal to B cos theta, that is B is 40 cos 45 degrees. So that is giving us 28. Yeah. Then our B in the x will be equal to B, in the y will be equal to B sine theta. So it's 40 sine 45. This is giving us also 28.3. Okay. Now, so we put this is I, J. Then our C, so if we go to the C, we'll do the same. So our C, our C is 30. So our C was 30. So we have 30 units. So our C in the x-axis will be 30. B again cos theta, so it's 30 cos 45. Now, we will not use 45, but we'll say cos 360 minus 45. All right. Yeah. So if we punch on our calculator, 360 minus 45. 360 minus 45. That is giving us 315. So we use 315. So this will give us 21.2 I. And if we say C in the y will be equal to B sine theta. So this is going to give us our C in the y will be equal to B sine theta. This is 30 sine 315, giving us minus 21.2 J. So to present them, that is what we have in unit notation. Yeah. Then also the resultant. So for the resultant, say R will be equal to AX plus BX plus CX I plus, in the y-axis, AY plus BY plus CY, yeah, J. So this is giving us R will be equal to 28.3 I plus 21.2 I plus 28.3 I. Then you add also in the y-axis, such that my board here isn't allowing me to go as far as I can go. You also add to the y-axis those values which you got. So it should give you something like as 49.5 I plus 27.1 J as the answer of our resultant. And just do this. Okay, I should give you something like that as the answer. So the next thing we do is finding the magnitude of the vectors and the direction. So for the magnitude, like always, R will be equal to the square root of Rx squared plus Ry squared. So y from those unit values, our x was 49.5, you square that one, plus 27.1 squared. Okay, So this will give us the square root of 3184.65. So our R in this case will be equal to 56.4 as our value. Okay, now we go to finding the direction. To find the direction, we say tan theta will be equal to Ry divided by Rx. So our Ry is 27.1 divided by 49.5 degrees. So our tan theta will be equal to 0.5474. Okay, so theta will be equal to tan inverse of 0.5474. Right, so tan inverse of 0.74, this will give us theta will be equal to 28.6995. 6. So theta will be equal to 28.7 degrees. So that will be our direction. Okay, so quickly let's look at our last question, not in the tutorial, that is question 6. So our question reads and says, a radar station locates a sinking ship at range of 17.3 kilometers bearing 136 degrees clockwise from north. From the same station, a rescue plane at a horizontal range of 19.6 kilometers 153 degrees clockwise from north with elevation point of 2.2 kilometers. Write the position vector for the ship relative to the plane, letting I represent east, J north, and K up. And B is how far apart are the plane and ship. Okay, so let's quickly look at the solutions. Okay, I know my diagram is a little bit awkward and filled with a lot of writings here and there. So this is just a simpler way to try and explain what has been given. So we have the station from the origins here. Yeah. Then from the origin we have a sinking ship at 17.3 meters away, which is that one, kilometers away, and clockwise bearing 136. Sorry, it's 136. Yeah, 136 degrees from north. The same station, a rescue plane at horizontal of 19 point something. So a rescue plane, this one, this route. Let me use the red one.